Now, let us talk about the inverse of a 2 by 2 matrix. To find the inverse of a 2 by 2 matrix, let's say of element A, C, B, D, we need to interchange the top left hand and the bottom right hand element. That is, we have D and A interchanged. Okay, so now we also multiply the other two elements by -1. So now we multiply the element C by -1, so we have minus C. Multiply the element B by -1, so we have minus B. So this gives us another matrix. Good. So we also go ahead to divide this resulting matrix by the determinant of the original matrix. So sometimes you may be required to first of all get the determinant before you continue. Okay, so what does that mean is we divide this resulting matrix by the determinant, which is 1 over the determinant is AD, that is the product of the diagonal, minus the product of the second diagonal, which is BC. So this stands as a form of a guide to help you to find or evaluate the inverse of any given 2 by 2 matrix. Okay, so let us quickly look at this question. Determine the inverse of matrix A equals 3, 4, minus 2, 1. Okay, so now let us first of all find the determinant or evaluate the determinant of this matrix, which is equal to, that is the matrix 3, 4, minus 2, 1, which is equal to the product of the leading diagonal, 3 times 1, 3 times 1, minus the product of the second diagonal, which is 4 times minus 2. Okay, and this gives us 3 times 1, 3, minus 4 times minus 2 gives us a positive number of 8. So 3 plus 8 will give us 11. Alright, so this is the determinant of the original matrix. Alright, so now let us find its inverse by dividing the resulting matrix by the determinant of the original matrix. That is, A raised to the power minus 1 equals 1 over 11, which is the determinant of the original matrix, to multiply the resulting matrix, which is 1, minus 4, 2, 3. Okay, you'll notice that the position of the left hand and the bottom hand element has been changed. Okay, you see 1, 3. All right, then the other two elements has been multiplied by minus 1. That's why we have minus 4 and 2. Okay, so this is the inverse of the given matrix. Another example, let us determine the inverse of this matrix. So first, let us evaluate the determinant, which is equal to the product of the leading diagonal, 2 times 8, minus the product of the second diagonal, 3 times 5. And that will give us 2 times 8, that is 16, minus 3 times 5 will give us minus 15. So 16 minus 15 will give us So its inverse is equal to 1 over the determinant, which is the determinant 1 over 1 times the resulting matrix. So now the resulting matrix is, we interchange the position of the two elements 2 and 8, so we have 8, 2. Then we multiply the other element 3 and 5 by -1, so we have -3 -5. Okay, so now 1 over 1 times the resulting matrix will still give us the matrix of 8 -3 -2 -5 2. Okay, so this is the inverse of the given matrix. So again, let us look at this another example quickly. Okay, so this time around we are to determine the inverse of this given matrix 6 2 3 1. So first we find the determinant, alright, which is equal to the product of 6 times 1 minus the product of 2 times 3. Okay, 6 times 1 is 6 minus 2 times 3, which is 6, so 6 minus 6 is 0. Therefore, this matrix is singular. The inverse of this matrix would contain the fraction 1 over 0. Since division by 0 is impossible, it follows that this matrix, this particular matrix, has no inverse. Okay, so every singular matrix which is equal to 0 has no inverse. Good.